Okay. So in today's session, we have to see about the buck boost and buck boost voltage regulator. In previous session, we have studied about the voltage regulator and the types of voltage regulator. We are using voltage regulator. It is a electronic device. It can be used to regulate voltage level. It means what? By using the voltage regulator, we can get the fixed output voltage that remains constant irrespective of the changes in the input voltage or the load condition. Because in previous session already we have studied about the parameters which we are using in the voltage regulator, like line regulations, load regulations. We have seen about these concepts. So line regulation is what? If there is a change in input voltage, at that time also there will be constant output voltage. It means what? We will get voltage amount constant at the output irrespective of the changes in the input voltage. After that, we have seen about the load regulation. It will depend on the value of output voltage. It means what? Here it is also independent on the changes in the load value. It means what? We can say voltage regulator as a load regulator if there is a changes in load, but irrespective of that changes in the load value, output voltage will remains constant. At that time we are saying that device as a load regulated voltage regulator. We are using here voltage regulator to get the constant amount of output DC voltage. Then we have seen about the temperature stability. It means what? If there is a change in temperature, if there is a change in amount of temperature, at that time also if we will get the constant amount of output voltage, that time we can say it is a temperature stable voltage regulator. Then we have seen there are different types of the voltage regulator available, and we are using voltage regulator because we will needed here the constant amount of DC voltage. So here we can say voltage regulator is used to regulate the output voltage. It will give constant, or we can say it will give fixed amount of output voltage irrespective of there is a change in input voltage or there is a change in load condition. So we can say it acts as a buffer for protecting the component from damage. Again, if you see, voltage regulator is a simple device with a simple feed forward design. And if you see the circuit diagram for the voltage regulator, we are using there the amplifier. So here we can say voltage regulator is a device which will uses the negative feedback control loop. It is using negative feedback loop because we have seen there are two types of feedback, positive and negative. Oscillator can use positive feedback and amplifier will use negative feedback, and in voltage regulator we are using the amplifier. So we can say voltage regulator will use negative feedback control loop. And if you see, there are different types of the voltage regulator. There are switching voltage regulator, there is fixed and variable. These are nothing but the IC regulator. Switching means buck boost and boost regulator. Then we have seen series and shunt regulator, in which we have seen there we can use Zener diode, there we can use BJT as amplifier to regulate the voltage. Then we have seen about the fixed and variable. In fixed, we have seen we are using 78XX and 79XX series as a fixed voltage regulator. Fixed means what? It will give fixed amount of voltage irrespective of changes in the input voltage. So 78XX, we are calling that series as a positive, and 79XX, we are calling that as a negative. If we are having 7912 IC, so we can use that IC to convert unregulated DC voltage into a DC constant constant voltage, and it will give us minus 12 volt, because 79XX or 79 double don't care, we are using that device as a fixed variable voltage regulator, but 79XX will give the negative. So it we can say it is the negative voltage regulator. Then we have seen about the adjustable, or we can say variable voltage regulator. In our syllabus, we have to study LM317 and LM337 voltage regulator. So we have seen already about LM317 and LM337. LM317 will be also a three-terminal device. We have seen fixed variable voltage regulator 78XX, 79XX. These are also a three variable. One terminal we are using for input, third terminal we are using for output, and second we are using as a ground in fixed variable fixed voltage regulator 78XX and 79XX. और adjustable या फिर variable में हम क्या बोल रहे हैं, we are having LM317 and LM337. If you see the connection diagram for the LM317, 337, these are similar, only there is difference in the pin diagram. If there is LM317, it will be also a three-terminal device. It will also look like this, but here first terminal will be used for adjusting the voltage level, because we are saying it is the adjustable, or we can say it is a variable voltage regulator. Then we have seen we are using here input, we are giving input to the third terminal, and at the second terminal we are taking the output. So here we can say if there is a LM317, at that time we will give its positive input, and at the output we will get the positive output. But LM337 will be having opposite pin diagram. It means what? Here input and output both are having the negative value, except remaining circuit will be exactly similar with the LM317 voltage regulator. Then we have seen some features of the adjustable, or we can say variable voltage regulator. In today's syllabus, we have to see what does mean by current boosting. So here we can see, as the name specifies, we can say boost means what? If we are increasing the value of current by using the voltage regulator, that time we can say that device as a current boosting. So this is the circuit diagram. You can see here. Here we are using LM317. It is nothing but, can anyone tell me which type of voltage regulator this LM317? It is a fixed voltage regulator, it is a variable voltage regulator, it is a switching voltage regulator, or it is a series or shunt voltage regulator? Namrata, please answer the question. Are you there? Pradnya? Pradnya? Okay, you can see here LM317 is nothing but the variable voltage regulator, and it is a positive voltage regulator. So what we can do here, this is the circuit diagram for the current boost voltage regulator. Here we are using variable voltage regulator, that is nothing but LM317. We are using here BJT, this is the resistor, and this is the voltage divider circuit. So here we can divide the voltage as per our requirement. So we can say this device can be used to regulate the voltage, and it will give increase in the current. So we can increase the value of current. So in switching type of voltage regulator, there are buck voltage regulator, there is boost voltage regulator, and there is buck boost. So buck means switch. If we are decreasing the value of DC voltage as compared to the input DC voltage, it means what? All the switching voltage regulator we are using as DC to DC converter. It means what? It will take input as a DC and at the output also we will get the DC voltage. But if there is a buck voltage regulator, at that time amount of output DC voltage will be less as compared to the input voltage. If there is a boost voltage regulator, at that time the output voltage will be greater than the magnitude of input voltage. And if there is a buck boost converter, at that time we can reverse the direction. The value of output voltage will be same with input voltage, but we can reverse the direction. So in today's syllabus, we have to see these three types of the voltage switching regulator. So here firstly we can see about the low drop output voltage. What we are saying, low drop means what? We are saying regulator we can use to convert DC voltage into a DC voltage, but at the output we will get increased or the decreased amount of the DC voltage as compared to the magnitude of input DC voltage. So LDO, it is nothing but the low drop output voltage. It means what? It will minimize the difference between input and output voltage, because by using the voltage regulator we want to get as a output, it will be a constant, it will be a regulated. So what we can say, we have to minimize the difference between input and the output voltage when it will be used to regulate the input DC voltage. So by using the low drop output voltage, we can minimize the potential drop between input and output. It can provide simple and inexpensive power management solution. So we can see here how will be the low drop output block diagram. So here we can see this is also a 3-pin circuit diagram. Here we can give input. This pin is used for the output. We are calling this block diagram as the low drop output voltage, and second terminal will be used for the ground. As we have seen, fixed voltage regulator 78XX, 79XX, the same circuit diagram. What is, we are using LDO as a 3-terminal device. At one terminal we are giving input, at the third terminal we are taking the output, and second terminal is reserved for the ground. So here we can see this is the circuit diagram for the low drop output voltage. Here we are using BJT. So here if you see at the output we are using here voltage regulator to regulate the voltage, to divide the voltage as per our requirement. So here we have to see switch mode power supply. If you see in our day-to-day life, we are using switch. So the basic concept behind the switch mode power supply is that we will negate the regulations by using the switching mechanism, because if we see here we have to see current boosting. So for current boosting we are, what we are saying here, you can see here we have seen series and shunt type regulator, because these are the different types of the voltage regulator. We have seen fixed and variable, these are nothing but IC voltage regulator. And now we are studying here our third type of the voltage regulator, that is nothing but switching regulator. So there are three different types: buck boost, or we can say invert, because it is inverting the input voltage at the output, or we can say flyback. So in switching, what will happen? We can use switch to regulate the voltage. So here in this PPT, you can see here we have to study about the switch mode power supply. It means what? Here we have to regulate the voltage by using the switch. So here we can say switch mode power supply, or we can say SMPS. This is the short form abbreviation for the switch mode power supply. So it is an electronic circuit that can convert the power using the switching mechanism. It means what? We can use switch to power on our TV, to power on the fan, AC. Like this, we have to regulate the voltage by using the switch. So here it is an electronic circuit that can be used as a switch. It means what? It can be used for turn on and turn off at the higher frequency and the storage component. And storage component, we know we can store some amount of charges by using the capacitor. Or we know if there is an inductor, at that time there will be magnetic flux get introduced, and as conductor will cut by magnetic flux, EMF will get induced according to the Faraday's law. This concept, we are aware about these concepts. So here we can say by using the switch we have to regulate the DC voltage by using the components like inductor, capacitor to supply the power when switching device is in a non-saturation or the non-conduction state. Because we know if switching device is in a non-conduction state, at that time we can use switch, we can use that device as a switch. So here we can say we can use SMPS circuit to regulate the voltage by using the switching mechanism. It means what? We can make device turn on or we can make device turn off at the higher frequencies, and we can use storage component to store the some amount of voltage by using the components like inductor and the capacitor. So here switching power supplies will have higher efficiency and they are used in variety of electronic devices including computer. If you see any electronic devices, most of devices will use switching mechanism. It means what? We can make that device as a regulated by using the switching mechanism, because these devices will have higher efficiency and other sensitive equipment requiring stable and efficient power supply. These devices will also use the SMPS. So we have seen about this switch. This switch is nothing but SMPS, switching mode power supply. So we can make that switch on or off. विशाल, मेरा आवाज आ रहा है अच्छी से? स्क्रीन दिख रहा है विशाल?
Yes, ma'am.
Okay, हाँ, you can mute yourself. Okay.
हाँ, ma'am.
Okay. So here we have seen about the SMPS. Now we have to study about the three types of switching power voltage regulator. So here we can say switching regulator circuit. If it is buck boost or buck boost, the switching regulator circuit will look like this. It means what? In switching regulator circuit, we are using SMPS. That SMPS is nothing but we can use that device as a switch, and that device we can take as a BJT or we can take it is as a MOSFET. Any device that can be, we can use as a switch. And by using the switch mode power supply, by using the switching mechanism, we can regulate the voltage. So this is the basic circuit diagram for switching regulator. Here we are giving the input voltage, that is also a DC. At the output, at the load, we will get the DC voltage, but that voltage will be in increase or decrease in amount as compared with the input voltage. It means what? Here we will regulate the DC voltage as per our requirement. We can use boost voltage regulator if we needed the higher amount of voltage regulator. Like if we are using the rectifier, at that time we are using the transformer. So transformer, what we are saying, there are different types of transformers, step down. So if we will needed the higher amount of voltage, that time we are using step up, means to increase the amount of voltage. और हमें decrease करना है तो हम step down use करते हैं. Like this, what we are saying, there is buck, there is boost converter. This is nothing but we are saying the converter, but it is type of the voltage regulator because it is converting DC voltage into a DC voltage, but that voltage will be in a fixed amount and that will be in increase or decrease as compared with the input DC voltage. So this is the circuit diagram for the switching voltage regulator. We are using here inductor and a capacitor as a storage device, and at the output we can take here any circuit that can be used as a load. So here I have taken resistor as a load. So this is the circuit diagram for the switching regulator. Here if you see we are using the Schottky diode. So this is the block diagram for the switch mode power supply. It means what? This is the switch mode power supply. For this, the circuit diagram will be what we are doing by using the switch mode power supply. We are using the switching mechanism to get the power supply at the output that will be regulated by using the switching mechanism. By using the switching mechanism, it means what? By using the SMPS, we can convert switching device, we can convert power using the switching mechanism, that are we can make that device turn on or off by using the components inductor and the capacitor, because that can store that switching device can store the. Is there any issue? Please don't disturb the class. Okay. So here we are using inductor and capacitor as the storage component because this can store the charges. So here you can see this is the block diagram for the SMPS. We will give input AC voltage and we can convert that AC voltage into a DC by using the rectifier and the filter. So you guys are from the second year, so you are aware about the rectifier and the filter. Rectifier means what? It is the electronic device that can convert AC voltage into a DC. If we are giving here AC voltage, at the output we will get fixed amount of DC voltage. We are using rectifier with a filter to minimize the harmonics. So here we can give that output which will be in the DC at higher frequency to the SMPS. This is nothing but switch. And here if you see we are using low pass step down transformer, because by using the transformer we can convert voltage to required amount of DC voltage. Again at the output we are using the rectifier. That output will be given to the sensor by using the isolation. It will be given to the oscillator and again it will get at the switch. So this is the block diagram for the SMPS. So in our syllabus we have to study about the types of SMPS. So by using the switching mechanism, we can regulate DC voltage to fixed amount of DC voltage that will be in increase or in decrease with respect to the input voltage. It means if there is a buck SMPS, buck SMPS, so we can use that electronic circuit to reduce the input DC voltage to lower DC voltage. It means what? We can reduce the input DC voltage into decreased amount of the DC voltage. If we require at the output higher amount of DC voltage, we can use boost SMPS. It means what? It can convert input AC voltage, input DC voltage, because all these switching वोल्टेज रेगुलेटर आर डीसी टू डीसी कन्वर्टर. हम ये यहाँ पे जो इनपुट दे रहे हैं वो भी डीसी है और जो आउटपुट में मिल रहा है वो भी डीसी है. सो बाय यूजिंग स्विच वी आर कन्वर्टिंग एसी इनटू डीसी. और फिर हम जब बक बूस्ट ये जो सर्किट यूज कर रहे हैं एट दैट टाइम व्हाट वी आर डूइंग ओनली वी आर इंक्रीजिंग और डिक्रीजिंग द डीसी वोल्टेज. सो इफ देयर इज अ boost voltage regulator, that time we can convert input DC voltage into a higher amount of output voltage. And if there is a buck boost voltage regulator, or we can say invert or flyback voltage regulator. So this is also a type of switching voltage regulator. Here we can use SMPS switching mechanism to convert DC voltage into a DC voltage, but at the output we will get the voltage that will be opposite in phase with respect to the input voltage. It means what? Here we are only inverting the input DC voltage. And if we are saying flyback voltage regulator, at that time also output voltage is less than or a greater than as compared to the input voltage. As well as here, by using the flyback voltage regulator, we will get multiple output. Matlab, if we have to reduce the input AC voltage, we can use buck voltage regulator. If we have to increase the input DC voltage, we can use boost voltage regulator. And if we are not supposed to increase or decrease the input voltage, only we want to change the phase of input voltage, we can use buck boost voltage regulator. And if we have to create the output at multiple times, so we can use flyback voltage regulator. It will also use the switching mechanism. You can see here the buck voltage regulator. This is the circuit diagram for buck voltage regulator. So here we are using input voltage, we are using here switching mechanism. You can use BJT, you can use MOSFET, or we can take here directly as this symbol as the switch. You can use any. तुम ये यहाँ पे ऐसे BJT कनेक्ट करो या फिर MOSFET BJT लिखो और एक switch का symbol दो. You can use any type of switch. So here by using the buck voltage regulator, what we are supposed to do? We are supposed to convert input DC voltage into a DC voltage, but that will have small amount of magnitude as compared with the input DC voltage. It means what? Here by using the buck voltage regulator, we can reduce the input DC voltage to required lower DC voltage. So if you see the circuit diagram, here we are using BJT as a switch. Here we are using inductor and capacitor to store some amount of voltage. Here we are using the Schottky diode. These devices we are using to convert input DC voltage into a fixed amount of DC voltage. It means what? We are regulating the input DC voltage. And we are giving pulse width modulation control to this switch, because we have seen the circuit diagram of the SMPS in which we are giving input as a AC, but we are converting that input into a DC by using rectifier, by using isolations, by using transformer, by using the PWM principle, pulse width modulation. So here we can say switch, and you can take as a PWM control instead of that much circuit. ये इतना बड़ा circuit ड्रॉ करने की जगह तुम डायरेक्टली यहाँ पे एक स्विच निकाल सकते हो, या यू कैन ड्रॉ हियर BJT और MOSFET and you can show here PWM pulse width modulation control. I have shown how current will flow, because what we are saying, by using the buck boost voltage regulator, we are regulating the voltage and we will get boosting current. It means what? We can increase the amount of current at the output. So here this is the circuit diagram for the buck voltage regulator. You can see boost voltage regulator. What is the difference? Here if you see, in buck voltage regulator, firstly we are using the switch, after that we are using here Schottky diode, after that we are using here inductor, after that capacitor. This circuit will remain same, a load or capacitor as it is. But here firstly we are taking here inductor, after that we are taking here switch, and यहाँ पे जो diode था, diode will go to this side. So this is the circuit diagram for boost voltage regulator. So what we can say here, by using the boost voltage regulator, we can increase the amount of input DC voltage at the output. It means what? At by using the boost voltage regulator, we will get higher amount of DC voltage at the output. So here if you see, here we are giving the input voltage at that time. If your switch will becoming closed, at that time you can see here it will behave as a short circuit. And if it is switch will behaving as a open circuit, at that time it will behave as a open and this current will directly flow to capacitor. But यहाँ पे when it is behaving as a when it is behaving as a closed switch, at that time current, some amount of current will flow through this side and some amount of current will flow through diode. So this is the circuit diagram for the whole boost voltage regulator. This is the type of switching voltage regulator. Buck boost we will see in next session. So here in today's session we have seen about current boosting. It means what? Here we can increase the amount of current at the output by using the switching mechanism. Here we are using the switch. So here you can see low drop output voltage is nothing but it will minimize the differences between input and output voltage, which we can use to regulate the input DC voltage at the output. So by using the LTO, we will get inexpensive power management solution. It means by using the LTO, we can regulate the output DC voltage by minimizing the difference between input and output. This is the circuit diagram for the LTO. SMPS is nothing but we are using here switch mode power supply. It means what? Here by using the switch mode power supply, we can regulate the voltage by using the switching mechanism. So it is a electronic circuit that converts DC power using the switching. SMPS will convert AC into DC. And by using the SMPS, we can provide the DC voltage to the voltage regulator. That will be buck, that will be bust, or that will be buck boost voltage regulator. So SMPS means क्या है? It is an electronic circuit that convert the power using the switching mechanism. It can use storage component as inductor and capacitor to supply the power, and that device we are using as a switch, it will be in a non-conduction state. We can use that device as because it will have higher efficiency and it is used in variety of electronic components. You can see here, this is the circuit diagram for switching regulator. It is buck boost. By using this circuit diagram, we can make different type of switching voltage regulator. So this is the basic circuit diagram for the switching voltage regulator. We are using here SMPS. So firstly, we will see about the SMPS block diagram. What we are doing here, SMPS को हमने क्या किया है, input दिया है and we are using inductor, capacitor, Schottky diode to store the voltage, and we can take here at the output load. So for SMPS, if you see, this is the block diagram for SMPS. SMPS can convert input AC voltage at the higher amount of voltage and the low frequency. It will convert input AC voltage into a higher DC voltage that will have higher frequency. Here we can use PWM oscillator, pulse width modulation, and we can use here rectifier and filter to convert AC voltage into a DC and to minimize the noise, to minimize the error. So there are different types of SMPS, buck SMPS, buck boost and flyback. If we have to reduce the input DC voltage to lower DC voltage, we can use buck voltage regulator. If we are supposed to increase DC voltage at the output, we can use boost voltage regulator. If we are not supposed to increase or decrease, only we are supposed to change in polarity of input DC voltage, we can use buck boost or a invert voltage regulator. If we are supposed to create output at the multiple output, that time we can use flyback voltage regulator. This is the circuit diagram for buck voltage regulator. If you see, this is exactly similar with this. This is exactly similar with this. We are using circuit diode, inductor, capacitor at the output load. And here we are giving here pulse width modulation controller. So we can take here, you can take here BJT. तुम यहाँ पे एक तो BJT या फिर MOSFET connect कर सकते हो. You can take switch symbol. And here we are using the PWM concept. So here you can show by using the one block. If the switch will behave as a short circuit at that time, if it is behave as a short circuit, at that time this input voltage will be given to Schottky diode and the inductor capacitor, and it will goes to the load. And if it will behave as the if it will behave as a open switch, that time input voltage will not go to this side. Here we are having the inductor and the capacitor as a storage component. So at that time, when switch will behave as a short circuit, at that time capacitor will store the charges, and when it will go for the discharging, at that time there will be some amount of charges because it is used as the storage component. So this is the circuit diagram for the buck regulator. We can use buck voltage regulator to regulate the input DC voltage, to convert that input DC voltage into a decreased amount of the DC voltage. So here we can see the circuit diagram for the boost voltage regulator. What is the difference? Instead of first switch, we are using here inductor. Uske baad we have used there in buck voltage regulator, we are using here diode, but here we are using a switch. After that, we are using the diode. So here, if it will behave as a short circuit, at that time input will go to the inductor, it will go to some amount of current will flow through this circuit, and same will go to the diode. And when it will behave as open circuit, at that time input voltage directly will go to the diode and the capacitor. So this is the boost voltage regulator. If anyone is facing any issue, you can ask me. Now I am taking your attendance. If you guys have not submitted the assignment, please submit the assignment. If anyone is facing any issue regarding assignment, test, or our today's lecture, you can ask me. We are having the 2 minutes. Saurabh? Saurabh? Okay. Huh. So we can finish our here today's lecture. Okay. Thank you.